Hello children, today we are going to discuss chapter 5, that is operators in Java. Teaching objectives of the chapter. Classification of operators or forms of operator. Precedence and associativity of operators. Counters and accumulators. New operator and dot operator. Okay, all these types of operators we are going to discuss. And at the end we'll be discussing data type conversion, that is type casting. Learning outcomes. Once we'll complete the chapter, you will be able to understand the different types of operators in Java, difference between prefix and postfix increment and decrement operators, conversion of one primitive data type into another primitive data type. Then first we'll see the definition of operators. Operators are special symbols that perform specific operations on one, two, or three operands and then return a result. Okay, so here all the operators are special symbols in Java, which will be performing a specific operations on the operands. Okay, so an operand can be variable or literal, that is value. Okay, so if we take example of this a plus b, this is an expression in which we have operator as well as operands. Here a and b both are variables, that is operands, and plus is an operator which is a symbol. Okay, now we'll see the forms of operators. Okay, so these forms are based on the number of operands required to perform that operation. Okay, so first unary operator. These operators operate only on one operand. Okay, examples of these operators are plus plus n and minus minus n. Okay, here only one operand is there with the operator. Here plus plus is an operator and also minus minus is an operator. Next, binary operators. These operators operate on two operands. Okay, so we need two operands to perform any operation using binary operators. Okay, you can see here example a plus b is a greater than b. All these are binary operators which need two operands to perform these operations. Next and last one is ternary operator, which is also called as conditional operator. Okay, this operator operates on three operands. Okay, in order to perform a ternary operation or conditional operation, we need three operands. Okay, basically here right hand side expression contains three operands. Okay, operand one is the condition, then question mark, then a. Operand 2 colon operand 3 is b here in the given example. Now first we'll discuss the arithmetic operators in Java. Children, already you know the basic arithmetic operators in mathematics. Now we'll see the symbols used for arithmetic operations in Java. Okay, so plus is additive operator, which is used to add two numeric values to get the sum as a result. Okay, in Java it can also be used with strings, which will concatenate strings, or it will join the strings to form a single string. Okay, so next one is minus, which is a subtraction operator, which subtracts an operand from another operand and gives us the difference as the result. Okay, the next one is the asterisk symbol, which is used for multiplication and gives the product as a result. The next one is slash, which is a division operator, which divides one operand by another operand and gives the quotient as the result. Okay, so it may look new to you, which is the percentile symbol, which is called as modulus operator or a remainder operator, which divides one operand by another operand and returns the remainder as a result. Children, now we will see the equality and relational operators. These operators are used for comparing two values. Okay, there are 6 relational operators in Java, namely equal to operator, that is equal to. It is used for comparing, for equality. Okay. It is not equal to. Two symbols are there here, exclamatory and equal to. It is not equal to operator. This is greater than, which is similar in real mathematics or life. Okay, this is greater than or equal to, less than, and less than or equal to. Okay, so all these operators are used for comparing two values. The result of a relational expression is always a Boolean value, that is either true or false. Means when we compare two values using a relational operators, result will be always either true or false. Only two possible values. Here what you should keep it in mind, that the symbols used for the operation. Okay, so equal to will be using two types when we are going to compare, and for not equal to it is less, exclamatory and equal to, and also greater than or equal to you should write like this. You should not use greater than or equal to, sometimes we use in mathematics. Okay, this is not correct. Similarly, less than or equal to should not use like this. Two symbols are there here and here, here and here. These things you have to keep in mind when you are using the relational operators. Basically, these are used to write the conditional expressions in Java, which will be used in conditional control structures in Java. So now we will discuss logical operators in Java. So logical operators will be performing operation on Boolean expression or a relational expression or conditions. And also the result of any logical operation will be always a Boolean value, that is either true or false. Now we will see the logical operators as per the syllabus. Okay, so we have logical AND, the symbol used is ampersand symbol twice, then logical OR, the symbol used is a vertical bar twice, and logical NOT, the symbol used is exclamatory symbol. Okay, so out of these three, first two are binary operators which need two Boolean expressions to perform logical AND or logical OR, and logical NOT is a unary operator which may need only one Boolean expression to perform logical NOT operation. Now we will see how exactly it is going to return the result when we use logical AND with the Boolean expressions. Okay, so logical AND returns true if all the conditions are true. In all other cases, it will return the false value. Now we will see logical OR. It returns true if any one of the condition is true or all the conditions are true. Okay, so it will be returning false value when all the conditions are false. In all other cases, it will return the true value. And logical NOT. Okay, so it will return the inverse of the Boolean value of the expression, that is logical complement operator. Okay, so if the actual value of the Boolean expression is true, so not true will make the result as false, or it returns the false value for true and true value for false Boolean expression. Okay, so it inverts the or inverses the value of the Boolean expression. Children, now we will see the truth table of logical and logical OR operators. So here we are considering two Boolean expressions, that is P and Q, and we are using the OR operator with the two Boolean expressions, that is P or Q. Okay, this is P or Q, and P and Q are both Boolean expressions. Okay, when we consider two Boolean expressions, the possible combinations are shown here. Okay, when both are true, when first one is true and second one is false, when first one is false and second one is true, and when both the conditions are false. Okay, so here, so you can see here in truth table, so OR operator is returning false value when all the conditions are false. In all other cases, it returns true result. Okay, so here you can see the OR operator will be producing the false result when all the conditions are false. Okay, you can consider even 100 conditions. If 99 conditions are false and one condition is true, so overall OR operation will be returning true result only. In only one case, the OR operator will return false when all the conditions are false. Now we will see the logical AND. Okay, so again the possible combinations will be same. Okay, so here you can see uh, the AND operator is returning true when all the conditions are true. In all other cases, the AND operator is returning the false result. Okay, so if you consider 100 conditions, if 99 conditions are true and one condition is false, then also the AND operator is going to return the false result. In only one case, the AND operator will be giving the true result when all the conditions are true. In all other cases, it will be returning false value. Okay, so these operators will also be used in conditional control structure when decision making statements are used according to the logic. You may choose either or and operator to get the result. Now we will see the simple assignment operator. The symbol is equal to. So one of the most common operators that you will encounter is the simple assignment operator, that is equal to or is equal to symbol. Okay, so it assigns the value on its right to the operand and its left. Okay, so here you can see an example. Int a is equal to 10. The meaning of this is the right hand side value, that is 10, will be assigned to a left hand side operand, that is here a. Okay, so here if it is an expression x is equal to a plus b, first the right hand side expression will be evaluated, the final result will be assigned to a left hand side operand. Okay, now we will see when we use assignment operator in our program, a compile time error occurs if the value assigned to an operand is incompatible type. Okay, so which cannot be converted by using implicit type conversion. In that case, we will get a compile time error like this. Int n is equal to 99.0. Here, double value is assigned to an integer data type, so which is not compatible. That is, compiler will not convert the double value into int implicitly, so it is compile time error. Okay, so if we assign compatible value, that is double n is equal to 99, that is integer, so that is compatible, so we will not get any compile time error. So compiler will take care of converting 99 into 99.00. Okay, so next, the assignment operators are syntactically right associative. They group right to left. Thus, so if we write this expression a is equal to b is equal to c is equal to 10, means uh, which assigns, okay, so which assigns the value 10. Okay, so it is from right to left. Okay, it is from right to left. First the value 10 will be assigned to c and value c to b, and then finally assigns the value of b to a. Okay, so assignment operators are right to left, or evaluated right to left or right associative. Okay, so here when we are going to use assignment operator, the left hand side operand may be a named variable such as local variable or instance variable, or it may be a computed variable. Okay, but it must be an operand. Now we will see Java shorthand or compound assignment operator. Okay, so general form of Java shorthand or compound assignment operators is operand 1 and operator. Okay, this can be any arithmetic operator as per our syllabus. Okay, then simple assignment operator, then operand 2. Okay, so if we write the expression like this using a compound assignment operator, it is equivalent to writing operand 1 is equal to type t is type of the operand 1. So operand 1 again, then operator. Okay, so which is mentioned here, then operand 2. Okay, now we will see the examples. Okay, so a plus equal to 3. Here plus equal is the compound assignment operator. Okay, it is equivalent to writing a is equal to a plus 3. Similarly, a minus equal to 3, which is equivalent to writing a is equal to a minus 3. Okay, similarly, a asterisk equal to 5 or a into equal to 5 is nothing but a is equal to a into 5 and so on. Okay, so if you find this type of expression, so it is nothing but compound assignment operator or shorthand assignment operator. It is equivalent to writing this way. Okay, so these are compound assignment operator. Whenever you are using this type of expressions, you can use or you can make use of shorthand or compound assignment operators in your program. Children, I hope all of you will be knowing the difference between simple assignment operator and is equal to a relational operator or equality operator, and difference between slash, that is a division operator, and modulus division or a remainder operator. Okay, so here we have three differences. So it is an assignment operator, it is an equality operator. So here assignment operator is used to assign a value to a variable. So this equality operator is used for checking the equality of two operands. Okay, so when we use assignment operator, it assigns a right hand side value to a left hand side variable, and when we use this in Boolean expression, so this will be comparing two values and it will be returning the Boolean value. Now we'll see the difference between a division and remainder operator. Okay, so it is the division operator, it is the remainder operator. So when this operator is used in operation, it returns the quotient after the division and it returns the remainder after the division. Okay, here is an example. When we divide 8 by 2, 4 is the quotient. Similarly, when we use mod operator or remainder operator with 8 mod 2, then we'll get 0 is the remainder. Okay, so children, now we will discuss very important operator, that is increment and decrement operators. Okay, these operators are unary operators, means these operators will be used on only one operand. Okay, so the symbols used for increment and decrement are plus plus and minus minus. Okay, now I will say plus plus. It is an increment operator. It increments a value of variable by 1. Okay, so then minus minus decrement operator, it decrements a value of variable by 1. Okay, so here the increment or decrement operators can be applied before. Okay, so before, that is prefix, or after, that is postfix the operand. Means since it is a unary operator which will be used on only one operand, it can be placed before the operand like plus plus n, or after the operand, that is n plus plus. Okay, so if it is used before the operand, that is called as prefix increment operator. If it is used after the operand, that is n plus plus, that is postfix increment operator. Okay, so the code result. Okay, so if we write this independently, result plus plus and plus plus result. Okay, here it is postfix and it is prefix increment operator, will both end in result being incremented by 1. Okay, so in this case, in the both expressions will be ending by incrementing the value of the variable result by 1. Okay, so the only difference is that prefix version, that is plus plus result, evaluates to the incremented value, where the postfix version, that is result plus plus, evaluates to the original value when it is a part of a larger arithmetic expression. Okay, so if you are just performing, this is very important, you know. Okay, if you are just performing simple increment or decrement, it does not really matter which version you choose. Okay, if you are writing means here, if you are writing independent statement, that is independently we are incrementing a value of variable in a separate statement. Okay, like n plus plus or plus plus n. Okay, it is not going to make any difference. But if we use this operator in a part of larger expression, okay, So the one that you choose make a significant difference. Okay, this will be seen with an example. Children, now we will see the difference between prefix and postfix increment operator. The first example shown is the prefix increment operator. Okay, here you can see in the method public void main int ax is there, a is equal to 10, and here this expression consists of the increment operator, that is prefix increment operator I'm using, and I'm assigning that value to a left hand side variable x. Okay, so since we use prefix increment operator, how exactly the expression will be evaluated? Okay, so till here already you know these expressions. Okay, so now when it comes to this statement, since it is prefix, first the value of the variable a incremented by 1, okay, will be incremented by 1, stores in the memory location of variable a. Okay, first the value of a will be incremented at this stage, because we have two operations here, one is increment and one is assignment operator. Okay, so which operation will be performed first matters here. Okay, then second, the value of variable a assigned to the variable x. Okay, here out of increment and assignment, since it is prefix, first incrementing of value of variable will happen. Okay, means value of a will be incremented by 1, then the value of a will be assigned to x. So here, since the initial value of a is 10, so first the value of a will become 11, that 11 will be assigned to x. Okay, so when we print a and x, okay, so both the values will be same. Okay, so in the same way it is equivalent to writing, okay, if I write x is equal to plus a, okay, so first it will, since it is prefix, first it will increment the value of a by 1. Okay, so it will store the incremented value in a, then it assigns value of a to x. Okay, so in this case the value of a as well as x will be same, that is 11. Okay, now you can see here, so output will be a is equal to 11 and x is equal to 11. Okay, so you can see here. Okay, so original value of a is 10, so first it will increment since it is prefix plus a. Okay, so that updated value or incremented value will be assigned to x. So here the value of both a and x will be 11 only. Okay, so now we will see the postfix increment operator. Okay, instead of using the plus a, if I use for same code, okay, if I use the postfix increment operator, how exactly it evaluates that this particular expression? Okay, here first the value of variable a will be assigned to x. Okay, so since it is postfix, the value of variable a will be assigned to x, means the initial value of a is 10, so 10 will be assigned to x. Second, okay, so the value of a will be incremented by 1, that is the value of a will become 11. Okay, so when we print this, the value of a will be 11 and value of x will be 10. Okay, so in this case you can check here, it is making a difference when we use in an expression either plus a or a plus plus. Okay, so it is equivalent to writing, it is equivalent to writing. Okay, so x is equal to a means first you assign the value of a to x, then increment. Okay, if it is postfix. Okay, so after assigning value of a to x, then the value of a will be incremented by 1, so x value will be 10 in this case, that is in postfix case. Okay, so here it is, you can see here. Okay, so here you can see first it will assign a value of a to x, that is 10, then it will increment because it is a postfix increment operator. So if it is decrement, it happens in the same way. Okay, decrement and use and decrement. Okay, so in the same sequence it, and now we will see what are counters and accumulators in Java program. It is a variable. A counter is a variable which is used to keep track of the number of times an operation or action has been performed. For example, you may be writing the logic to find number of characters in the given string. So generally, counting starts from 1. So each time we will be incrementing the value of variable by 1. So directly you can use the counter C++ or C is equal to C plus 1. When we count, each time we will be adding 1 to the previous number. Okay. So in case it is a countdown, okay, it may be from top to bottom, highest to lowest. That case, each time we will decrement the value of variable by 1. It can be C minus minus or C is equal to C minus 1. And next, accumulator. Accumulator is a variable that the program uses to calculate sum or product of the series of values. So it is a variable which will be accumulating the sum of the terms in the series. So initially we'll make it as 0. Okay, sum is equal to 0. So additive identity is 0. So expression like this, S is equal to S plus 2. Okay. So in this case, you can also use a Java shorthand operator. Okay. So it can be variable S is equal to S plus I. This will be used when you are asked to find sum of the series or product of the series. Okay. So here we can also use Java shorthand operator. And now we'll discuss conditional operator in Java. The symbols used in this operator are uh, question mark and colon. Okay. So it is alternative to if then else, which is conditional control structure in Java. So it is also called as conditional operator. This operator is also called as ternary operator because it uses 3 operands. You can see the syntax here. So operand 1, question mark, operand 2, colon, operand 3. Here we have 3 operands in the operator. Okay. So this particular statement can be read as if operand 1 is true, assign the value of operand 2 to result, or else assign operand 3 to result. Now you see children, when we read this expression, we can guess the types of the 3 operands in the ternary operator. So since here it says that if operand 1 is true or false, it will be a Boolean expression or simply a condition. And since here there is a condition in operand 1, it is called as conditional operator. Okay. Now you can guess the value or type of the operand 2 and operand 3. Okay. For this particular example, so the data type of operand 2 and operand 3 will be the compatible with the result because the value of operand 2 and operand 3 will be assigned to the result. Then we give operand 1 will be always condition whose value is either true or false, and operand 2 and 3 are compatible type with the type of the latest variable if we use in this way only. So here is an example. So int large equal to n1 is greater than n2 question mark n1 colon n2 where n1 and n2 and large are integer data type for this compatible. Okay. So here if the Boolean expression is true, so value of n1 will be assigned to large. If the Boolean expression is false, then the value of n2 will be assigned to large. In general, this particular statement is returning the largest among two numbers as per the logic. And now we will see the precedence and associativity of operators in Java. Okay. Precedence. It is a priority of an operator according to which it is evaluated. Okay. So what is associativity? If two operators have the same precedence, that is same priority, then they are evaluated from left to right or right to left depending upon the operators which we are using in the expression. I will see in detail. So the operator in the given table, okay, so are according to the precedence order. Okay, so from highest precedence to the lowest precedence. Okay, so operators with higher precedence are evaluated before operators with relatively lower precedence. Already you know the BODMAS rule in mathematics. So in the same way, in Java also, each operator having its own precedence. Okay, so when operators of equal precedence, okay, here you see uh, in this row, so here you can see multiplication, division, and modulus division. Okay, all are having same precedence. If the expression is having these operators only in the expression, so how exactly these will be operated, that is called as associativity. Okay, so all the binary operators except assignment operator will be evaluated from left to right. Only the assignment operators evaluates from right to left. So now we will see the important operator, that is new operator. It is a keyword. Okay, so this keyword is used to create the object and allocate a memory for the members of the class. Okay, so it creates an object, also it allocates memory for the members of the class. Here is the syntax. Okay, name of the class. Okay, here we have taken student as example. Okay, so here name of the object, that is an identifier. You can choose any appropriate name following conventions, then equal to, so new keyword and student method. Okay, so here it is a special method whose name is same as the class name, that is called constructor. Okay, so this complete statement creates an object and also allocates memory for the members of the class. Here if you consider student one object, okay, its members are roll number, name, admission number, and group as per the example. Okay, so after allocating memory, the reference to these members will be stored in the object, that is student one. Now we will see the dot operator. Okay, so in order to use objects, we will be using dot operator. Okay, so already you have used the variables or data members in your program. So data members are variables are accessed by their own names within its own class. Okay, so directly we will access the variables in its class. Code that is outside the object's class must use an object reference or expression followed by the dot operator. Okay, in order to use a variable of one class in another class, then we need to use object reference followed by dot operator and followed by a simple variable name as in. Okay, so object reference dot variable name. Okay, so here uh, it indicates that this particular variable or data member belongs to a class from which you have created the object. Okay, so you also use an object not only with the data members. Member methods will also be accessed or invoked by using the object reference. Okay, so you append the method simple name to the object reference with an intervening dot operator. Okay, so you provide within enclosing parentheses any arguments to the method. Okay, if any arguments are there for the method, you will mention, otherwise we will leave it empty. Okay, so if the method does not require any arguments, use empty parentheses. Okay, here is an general syntax how we will be invoking the methods of any class. Okay, object reference dot method name, argument list if any, or object reference dot method name parenthesis. Okay, so here we use object reference with the dot operator. Okay, in general, dot operator is used to access the members of the class, that is variables and methods of the class. So now we will discuss the type conversion in Java. Here type is data type. Converting one primitive data type into another is known as typecasting or type conversion in Java. Typecasting is technical term for type conversion in Java. So here we have two types in typecasting. One is implicit type conversion, which is also called as widening. Here the conversion between from lower data type to higher data type, and it is by compiler. Okay, so compiler means it is a automatic type conversion, so it is called as implicit. Okay, so compiler will take care of converting lower data type to a higher data type. Okay, so explicit or narrowing. Okay, so in this case, converting a higher data type to a lower data type with the user intervention, that is programmer need to mention from which data type to which data type you are converting. So now we will see the detail about implicit type conversion. Okay, so here the conversion is from lower data type to higher data type. You can see here byte will be directly converted into short, and char will be to int, and short will be int. Means if we assign short value to integer data type, so the conversion from short to int will be happening automatically by the compiler. So it is also called as implicit type conversion. Okay, when we do this type of conversion, uh, the numeric value remains same. Overall magnitude or numeric value same. We are not going to lose any information. Only the type of the value will get changed. Okay. Suppose if you assign int value to a double. Okay, double n is equal to 99. Okay, 99 is here integer. So compiler will convert 99 into double, that is 99.0. Only data type of that value is changed in that particular expression, but overall magnitude of that numeric value will remain same. Okay, so here is another example which you need to understand at this stage. Okay, so here you can see you can also assign character value to an integer operand. Okay, so in this case what happens, how exactly character value will be converted into int? You can see here character ch is equal to capital C, and I am assigning that ch value to a integer variable. Okay, here ch is having a character C. All of you know that each and every character in Java will have its Unicode value. Okay, so here all Unicode values are positive integers in general. Okay, so that Unicode value will be stored in Unicode or ASCII, both are same for uh, characters. Okay, in this case, so here ASCII value of capital C will be assigned to I, and when you print 67, which is nothing but the ASCII value of capital C. This is also an example of implicit type conversion. And now we will see the explicit type conversion or narrowing in detail. Okay, so in this type of conversion, a higher data type value will be converted into lower data type. Okay, so in this case, hence in narrowing is not done automatically. You need to convert this using typecast operator explicitly. So it is also called as explicit typecasting. Okay, so in this case, both the data type need not be compatible with each other. Okay, so when we convert from higher data type to lower data type, there is a chances of losing precision or overall magnitude of the value if you are using numeric. Okay, so here you can see uh, a double value can be converted into integer explicitly, but there is a chances of losing precision if double value has a precision or decimal places. Okay, so in this case you can see, so double can also be converted into any other lower data type using typecast operator. Okay, here the syntax is you can see with an example here. So here we are converting int to a character. Okay, that is integer data type to a character data type. Okay, int I is equal to 65. Now you can see in this particular example, so this is the cast operator. Okay, so here what we are doing is character cs is equal to char in parenthesis and I. Okay, here I is integer, so we are instructing compiler to convert the value of I integer into character and assign that character to a LHS variable ch. Okay, in this case, what happens? Already you know that each and every character has its ASCII value. Okay, in this case, what happens? It will extract the ASCII character from the table whose ASCII value is 65, and that character will be stored in ch. This is an example of the explicit type conversion. Okay, so the character for ASCII value 65 is capital A. So capital A will be stored in ch when we print this. Okay, so capital A gets printed because capital A is stored in ch after explicit type conversion. Okay, so if you take another example, int I is equal to, suppose if I write int in parentheses and 99.9. Okay, so here it will convert that 99.99 into 99, and that value will be stored in int n. This table is for reference. So ASCII or Unicode range for uppercase letters. Okay, so it is in a sequence. Okay, for capital A it is 65, and capital B 66, and so on. Capital Z it will be 90, and lowercase letters A to Z. Okay, so for lowercase a, the ASCII value or Unicode value is 97, and for small b it would be 98, and so on. For small z it would be 122. You can see the difference here. 32 difference is there for capital A and small a. Okay, for 0 to 9 digits, for 0 it is 48, and for 9 it is 57. For space, the ASCII value is 32. This is for a reference only. Now we will discuss the output statement used in Java program. So already we have used the output statement to display the data onto the terminal window. We have two methods, that is system.out.println and system.out.print. Okay, so we'll see the difference now. When we use system.out.println, okay, so to print some data, after printing data, the cursor will be moved to the beginning of the next line. Okay, so if I use system.out.print, so after printing data, the cursor remains on the same line after printing the data. Okay, so if any print statement is there after this particular println statement, the printing takes place from the beginning of the next line. Okay, in this case, if any print statement is there, the printing takes place on the same line. Okay, so here if you see the example, so in this case, system.out.print. Okay, so if I use this statement, okay, so after printing Johnson, so type here, after printing Johnson, after printing Johnson. Okay, so here it is Johnson. Okay, so since it is print, cursor will remain on the same line here. So since one more print statement is there, that is going to print grammar, so grammar will be printed on the same line only. Okay, that is Johnson grammar. Since ln is there, after printing grammar, cursor will be moved to the next line. So one more print statement is there, that is println. After printing school in the next line, again cursor will be moved to the next line. So it will be printing Johnson grammar on first line and school in the next line. Okay, here Johnson and grammar, and there will be no space. Okay, you can see here. So cursor will remain after printing Johnson there only, and it starts printing grammar immediately. After printing grammar only, cursor will be moved to the next line because of println, and then school gets printed in the next line.